Hey everybody, welcome back to Brain Sprain. Today I'm going to be bringing you a puzzle that I came across in one of the competitions I was in earlier this year. These competitions have a whole wide variety of different puzzles to do, ranging from network security to forensics and just uh, open source intelligence, things like that. So this one in particular was one part of the forensics category where we had to solve a problem involving a gambling site was the environment we were in. And I'm hoping to walk you through that and how I did it. It's a beginner-ish problem, so if you're just starting with Python or cyber competitions, I definitely recommend watching the rest of this video. It's a good look into how those problems lay out. Yeah, so with that, I'm going to get into it, give you a little bit of the background of the problem, see what we're looking at, and then I'll walk you through it along the way and give you the opportunity to pause the video and go and solve it for yourself if you want to. I'm going to get my head out of the way and then we will rock and roll. Cool. So the puzzle started with giving us a website. This website actually, I like duplicated it on my own machine, but it's pretty close to what we got in the competition. I'm doing this by running a web server on a virtual machine I built. This is a Linux virtual machine. I can show you where I put all the folders. It's running an Apache web server, so the folders are found in this directory. Uh, the background of the puzzle was that this company, gambling company, is running a website that has user information on it, which right off the bat you know is a bad sign. But there were these. Obviously, we have a thousand folders here, each containing. I'm gonna just go into one for example. Each containing this .sha1 file, which if you aren't sure, a SHA-1 file contains a hash. So I can actually write this out to the console right now. This string of characters right here is called a hash, and it's a representation of data in a formatted way, I guess is how you would put it. Some people could call it encrypted. I guess it is encrypted in a way, but usually when I think of encryption, I think of something that can be reversed, which hashes can't. You can think of hashes as taking an orange and making it into orange juice. You can't take the orange juice and put it back into the orange. It's kind of the way it is now. So the way hashes work is you can give it a password or a document, like a Word document, or even the data of an entire hard drive. And it's going to print out this string of characters that represent that data. And they're always going to be the same length. They're always going to come out to the same thing as long as you give it the same input. So for example, in this instance that I want to show you here, I want to work with passwords. So if I were to type in a password, say this pass, and generate the hash value for that, we get this, the last three characters here are E9E. So again, we have this whole string of characters, but the last three I'm just going to look at just to make it easy to follow are E9E. This is a random website I found online, md5hashgenerator.com. It just gave me the quick hash for it. I'm going to go to another website I found and type in this pass, generate the value for that, and we get the same thing. It's the same length, has the same characters in it, and it's the same representation of that word. I can also do this in Linux. I can run a command and echo that value. Oops, I need that there, and run it through Linux's MD5. And we get the same value here, E9E, same length. And let me show you how, if I type in a much longer word here, this password is long. See how we get the same length of a response, it's just a different value. And I can change something as simple as the last character here. We're going to get a completely different string at the end here. So just a quick overview of how hashes work. They're really great for managing the integrity of data, and they're good for hiding passwords and making sure that you're getting an encrypted version of it, kind of. but making sure that they remain the same. So anyway, back to the puzzle here. I just printed out the content of one of these files, and we can see that we're getting hashes. Now this is the same across the board. All 1,000 of these folders have a file within them that has a hash value in a SHA-1 format. Now, the reason that is let's go back to the background of the story. So we're running this gambling site, and each of these folders represents a user or account holder on that gambling site. Now, the puzzle told us that some of these accounts were bots, and that was bad because they were messing with the gambling site and basically scraping money off the top of their profits or something like that. So we needed to find the number of bots that were on the gambling site and report them to the company. Now, the puzzle told us that we'd know if they were bots if their hash values in an MD5 format, or I'm sorry, in a SHA-1 format, hashed out, or if you plugged in 000, 0000, or 00000, so 3, 4, or 5 zeros, if you plugged in that to the SHA value, it would equal that hash. So that probably sounded really confusing, but let me show you an actual example here. So 3 zeros, 4 zeros, or 5 zeros. Now you can see these are the hashes for an MD5 that we'd be looking for. We would need to find these in any of the files. If any of the files had these, now just a reminder here, MD5 is different than SHA-1, which we'll be working with, but the same concept applies. So if any of the files had these or any of these hashes in them, we'd know it was a bot. I hope you're keeping up now, because obviously we're not going to find the plain text values of these in the files. We need to be looking for these hashes instead. Now, the reason we know that they'd be bots is because every time we make the hash, it's going to be the same. So if we can find the hash of these values, then we know it's that password or user ID or whatever we'd want to call it. So it's kind of like a reverse hide and seek almost, where we know the answer. We just need to find the answer to know we have the right value. I hope that made sense. That was a long-winded version of it, but that's kind of like the background there is. Now, if you want to solve this puzzle for yourself, go ahead. I have all the materials on my GitHub to do it. Read through my background in the README file and build it out for yourself. But at this point, I'm going to go on and walk you through how I solve the puzzle myself. So stop if you want to try it on your own. Stick with me if you want to see how I did it. Alright, so like I said, I found the website with 1,000 folders on it, each with their own SHA-1 file. At that point, I figured out, I kind of walked through what I wanted to do. One, I wanted to download all the files to my computer from every folder. Two, I wanted to combine all of those files into one file, so take the hash value from each of the SHA-1 files and put it into one big text file. And then three, go through every line in that text file and compare the hash to the hash of the zeros. So the SHA-1 hash of these three, I'll call them passwords, but these three values. And if they matched, I would increase my zero counter by 1. And when I made it through the whole file, I'd print out my zero counter and see what it was, and that would be my answer. So yeah, with that, the first step I took on was downloading all of those files to my computer, which I can show you by going to, here we go. I needed a PowerShell prompt to do this. So I opened up a PowerShell prompt in the folder that I wanted to download all of these files to. And I ran a PowerShell prompt to do it. which I can show you. And where is it? I hid it somewhere, of course. Oh, I think I remembered where I put it. It's a wget command, which has trouble working in Windows sometimes, but you can download the whole wget package from online, and it's actually really simple. It's just a wget r tag. So the R means recursive, and that goes through every folder in the tree you give it to download all the files. And after you give it the -r, you just give it the website name. So in my case, it was a simple 10.100.200.167 was the website. And after hit enter here, it'll go through and download all 1,000 folders and then each file within those folders as well. Now, as you can see, I already ran that command, so I'm not going to run the whole command again to show you all the downloads. It took a bit of time, but it wasn't very long. So after I downloaded all those files, I worked through PowerShell again and found a command online because I'm not 100% smart enough to figure it out on my own. But I knew I wanted to iterate through every folder and combine each of the files into one file. So the command I found online for Windows was this guy, which if I looked at it and tried to understand it, I'm not going to pretend I do, but if I were to try to analyze it myself, I can obviously see there's some kind of for loop going on here. The /r, I'm assuming, is a recursive for loop, and then I want to look for every file that has a .sha1 extension. So it doesn't matter what the beginning part is, all I'm looking for is the extension part. And then, so this kind of defines what we're looking for, and then after that, we want to type whatever the contents of that file is into, or I do know what this means, this is append, not write, and append that into my file, mergefile.txt. So I ran that and printed it out into my, actually didn't run that yet, let's see. See how long that'll take. Oh, that errored out, of course. Oh, I think I had to do this in command prompts, maybe. Crap. What if I opened up the command prompt? Desktop puzzle. Alright, what if I paste it into here? Come on, give me. There we go. So I had to run it through command prompt, not PowerShell. So you can see it's going through each of those directories, grabbing all the file names. That you can find that right here. I was going through all those, and then it's done. So now I should have a file. Yep, mergefile.txt. So if I were to type out that one, mergefile.txt, I have 1,000 lines here of SHA-1 hashes. Now, I know that some of these hashes are the result of 000, that was 3, 4, and 5 zeros that are going to be in here. I just need to find out how many of them there are. After that, I went over to just the text editor. My preference is Atom. My preference for text editor is Atom. And I built out a countbots.py. I knew I needed to use the hashlib library, which if you aren't sure of, check out my GitHub. I have a file that can walk you through it. And OS I added in later, as you'll see in a second. This was after the fact. So I pasted in my comments, just each command to use for Windows and Linux because I knew I'd forget them, which is what I copied over. I set my counter equal to 0, and this whole piece right here added in after the competition. This did exactly what I just did in command prompts, where if my operating system was Windows, it ran that big for loop and combined it into mergefile. and then I gave the option for running it in Linux, where it would run the Linux equivalent of that. So I'm going to skip that part. And then the only other piece that we did was we opened up the merge file.txt as a read-only, and we ran a for loop, and that was it. we ran a for loop, compared each line to the SHA-1 hash of 000, 4 zeros, and 5 zeros, and compared it to each line of that file. I made them all lowercase just to make sure that the hash result didn't change from the hashlib library versus the string of the file that we were looking at. But I mean, this kind of looks complicated, but it was really super simple there. This part was easy as cake because it was just an if-else statement, and then if they matched, we increased our counter by 1. If they didn't, we just skipped it and moved on. So by the end of it, we print out how many bots we found, and I submitted that and got it on the first try. So all in all, it took me like 20 minutes because I've had experience with the hashlib library in my past crack project, but it really wasn't overly difficult. The logic was really simple, and even if you didn't know how to use hashlib at all, you probably only need another 10 or 15 minutes to figure it out. So this was a pretty straightforward project. Definitely recommend trying it for yourself and maybe finding another way to do it. Another way you could have worked with the files themselves, maybe open up each file individually, like skip combining it, and instead compare each file against the hash of these 3 values and see if that works. Or find a different way to download all of those files from your web server. Now, you may not have access to a VM. This VirtualBox, the hypervisor I used, is free. You can download that for yourself and build out an Ubuntu machine, which is also free, and build out a Apache web server, which is also free. So you should be able to do all of these if you wanted to. It's just a matter of learning how to if you're not sure. Yeah, so that's how I did it. If you went to my GitHub and if you didn't know how to do that VM stuff and build out your own, I made a file, or I made a Python script to do that for you. It just built all of those directories locally. So it generated a folder with 1,000+ directories. Now, I made an intention call here because it builds them in your current directory. So make sure you're in like a throwaway folder, for example, that you don't care about, because it'll create 1,000 folders in the directory you run the script in. So like you wouldn't want to run it on your desktop, for example, because it would create 1,000 folders on your desktop. Create like a puzzle folder and run it in there instead. But that'll build out the whole environment for you, and it'll write the number of bots it created to a secret num file and allow you to discover that for yourself, because it is random. I used the random package to randomly choose how many bots to create. All right. Yeah, so I hope that was a interesting idea for you. I don't see that kind of problem very much in cyber competition, so it was a refreshing to see it. But I hope you enjoyed it. Until next time.